So let's try an example of calculating the pseudo-inverse. So let's say that you are given a weight vector, or sorry, you're given some samples. You're given that you have these two features, x1 and x2. Here's your sample 1, sample 2, sample 3, sample 4. The values are given as such. And you're also told the class that they belong to. Out of two classes, the first two samples belong to class 1, and the other two samples belong to class 2. Okay, so here's the important part. If you're just going to watch the first minute of this video, then you should just listen to this one part that I'm about to say. So that's pseudo-inverse definition. This is the important part. I'll write it out. You can do something else while I write this out. You can like look at memes or something. So this pseudo-inverse definition here, this will work if you define your vector of features x such that every row represents a sample. Okay? So if you define it like this. And then if you go on to augment it like this. Okay, so if you define your sample vector so that every sample is a row, so this is sample 1, right? This is sample 1. This is sample 3. If you define it this way, then this formula for the pseudo-inverse is going to work. But if you define it so that every column is a sample like this, then this formula will not work as it is written. You would have to, I know that to get the equivalent of like this part, the part that's inversed, you'd have to change the order of what's being multiplied here. But in my very brief experiments, I didn't find a way to get this multiplied by this in such a way that it would get an answer that's the same as if you just define your x vector such that every row is a sample instead. So yeah.